Optimization problems presented by Cartoon, Q, and Pound. Optimization. So, optimization is maximizing or minimizing some function relative to some set, often representing a range of choice available in certain situations. Okay, but what is this? Q. Help. Please. This question, I can't do it.
I can help you. So let's go to the question 1. 16 feet of goth is to be used to form a square and a circle. How much of the goth should be used for the square and how much should be used for the circle to enclose the maximum total area? So for the solution, we know that the total area is equal to the area of the square and the area of the circle. So we substitute the equation by writing a equal to x squared plus pi times r squared, which is the primary equation. Because the total length of the goth is 16 feet, you can obtain that 16 is equal to the perimeter of the square plus the circumference of the circle. So we can write the secondary equation as 16 equal to 4x plus 2 pi r. So from the secondary equation, you can take r equal to 2 parenthesis 4 minus x parenthesis all divided by pi, and by substituting into the primary equation, you will get a equal to x squared plus pi times 2 times 4 minus x over pi all square. Simplify and then we get x squared plus 4 times 4 minus x squared over pi. And then simplify again, you will get x squared plus 64 minus 32x plus 4x squared all over pi. And so we know that the feasible domain is 0 less than or equal x less than or equal 4, as it is restricted by the square's perimeter. And because dA dx is equal to 2x plus 8x over pi minus 32 over pi, we can know that the only critical number in the interval from 0 to 4 is x is equal to 16 or pi plus 4, which is around 2.24. By using the formula of finding the critical number by substituting the first derivative of the area equal to 0 times pi to both sides, we will get 2 pi x plus 8x minus 32 equal to 0. Add 32 to both sides, we will get 2 pi x plus 8x equal to 32. Pull the x out, then we will get bracket of 2 pi plus 8 times x equal to 32. Divide both sides by 2 pi plus 8. We will have the x value of 32 over 2 pi plus 8. Simplify again, we will get the final x value of 16 over pi plus 4. So using the both integral x value, which is 0 and 4, and the critical number that we find earlier. So by using these three x values, we can have three different total areas, which are a to the x equal to 0 is around 20.37, a to the x equal to 2.24 is around 8.96, and a to the x equal to 4 is around 16. So we can conclude that the maximum area occurs when x equal to 0. That is all the word is used.
Thanks. How about that paper?
The paper with the 14 times 18 inches would be 18 minus 3x divided by 2, which is the length, and the 14 side equal to 14 minus 2x, which is the width. Volume is x times 18 minus 3x divided by 2 times 14 minus 2x. We cut those two. And we got 3x cubed minus 39x squared plus 126x. After that, we differentiate and got 9x squared minus 78x plus 126. Pull the 3 out and find the answer. So the answer is 6.519 and 2.148. So our x and height are 2.148, and we return back to the first question to find length and width. So the maximum volume is 5.778 times 9.704 times 2.148, and the answer is 120.438 inches cubed.
Thanks you guys a lot for helping me. Hope you enjoyed the video. Bye!